I'm here in Rockville, Maryland. Luther Kruger with the Big Blue Sun Museum of Solar Cooking, out of Minneapolis. I'm here with Paul Arvidsson, Solar Household Energy Inc., famous for the hot pot. And before we even get underway, the one thing I got to say is I had a huge bias against panel cookers until I got the hot pot. And I realized, well, they're all set up to do some kind of heat trap thing. And I just looking at them, I didn't think they could really work that well. But that totally blew me away. That's their claim to fame. But I always have three questions. One is, what got you into solar at all, and then maybe solar cooking in particular? And then where are things now with solar household energy or any other projects you might have going? And what do you feel the future is, and maybe some tips on how people can promote solar cooking?
Okay, great. Well, let's take number one. Going back, I guess, back in the 70s, and this goes way back, we had kind of an energy crisis and a gas crisis and so forth. You might remember that. And I had just bought a new house, so I was interested in environmental energy stewardship kind of things. I'm a Christian. I have an interest in values like that, and I also was trained as a physicist, researcher, and I put those things together. So I worked on my house, got a lot of improvements made on it, and of course that was the first generation of folks that kind of got into solar energy, solar panels, things like that. And then, there was quite a hiatus, there was quite a gap, and then now, of course, solar panels have come down a lot in price. I have some here on my roof, and it didn't cost me a dime. I just got a purchase power agreement, start paying a bill through what was then Solar City. It's now owned by Tesla, and it's very convenient, and it just cuts down on my total electric bill. So what's not to like? I wish all my neighbors around here would do that. We have a lot of trees. This is Tilden Woods, it's called, this subdivision, and so we have a lot of woods, a lot of trees. But fortunately, I've got some sun in the daytime, in the afternoon here. That's pretty nice, and so it made sense for us to just put the solar panels up when we bought this house. But then about 2005, I retired, and I kind of got asking, well, what do I do? I have my physics skills, my humanitarian interests. How do I put that together? And I know a lot of people were working on things like water projects, and I didn't want to do something that everybody else is doing. And so I discovered this idea of solar cooking, started investigating a little bit, and I discovered, the organization out in the West Coast, Solar Cookers International, and then I discovered this local organization, Solar Household Energy, that was run by Darwin Curtis, as you mentioned.
Yes.
Now, Dar Curtis died last year, but he was an inspiration to me and a lot of us around here to get into solar cooking. And so I started doing some simple experiments with solar cookers and using his hot pot. We have a hot pot setting back over here. And then I started thinking, well, what can I do with the scientific side of this? I know there's a lot of hobbyists that get into this, a lot of enthusiasts around the country that just do it for fun. Maybe they do it for a camp trip or Boy Scouts or something like that. How can I get a little deeper into this? And so in around 2015, I started making systematic measurements of various solar cookers to test, mainly to find out how much power do they put out. And so, well, I'll tell you a little more about that later. Sure. Now, what was your next question?
Oh, it's just where are things now?
Okay.
That's how you got into solar cooking, and now solar household energy, the hot pot in particular. I guess the specific question is the design. How did that come about?
Oh, okay.
Yeah.
Right. Well, we have a great team of people around the DC area here. The co-founders of Solar Household Energy were Dar Curtis and Louise Meyer. And Louise Meyer has been very visible around the DC area. She does displays, projects, and demos She has been all over the world. She works for State Department, so she's very aware of the needs around the world for these things. We had Pat McCardle worked with us for a time here. She kind of recruited me to get more involved in this. So I began to learn about all the people in this field of solar cooking in the U.S. It's not a big field. It's not a crowded field. You can kind of get to know everybody. And that made it even more interesting, you know. And so I'm glad you're doing this, because you're getting us all, helping us to get acquainted with each other and build more of a community of people. Yeah. My mother lives in San Diego. She's 106 now. She's doing fine. She's doing great. I was talking to her on the phone last night. And she is in a nice sunny area, so I like to go out and visit her. And I met Roger Haynes out there. He lives in Del Mar, near San Diego. And Roger developed these solar cookers, Haynes Model 1, Haynes Model 2 there. As you can see, they're very lightweight and fluffy. We got a little wind today, so one of them is just blowing around. We should probably put a brick on the side of them to weigh them down, you know. But at any rate, that's I liked what Roger Haynes was doing, because he's got a cooker that's as powerful as the hot pot, or even more, but it's a lot lower cost. So the hot pot is a great solar cooker, and Dar Curtis manufactured 20,000 of them. They were distributed all over in Mexico and in other areas, and they're still widely known around the world. We took some to Africa, demonstrated them there. I have a picture, I'll show you. Sure. We did an exam in a place in Chad, in a refugee camp in Chad. And you see that this is an example of a woman with a hot pot out in the desert. They don't have much wood out in the middle of the desert, so they are using these hot pots. And you can see places. We look at, you know, the GIS maps, like you're familiar with that, right? Yeah. That show the red areas where the sun is shining a lot, and that's where places like San Diego are pretty good. So, you know, as I got into solar cooking, I began to realize that it really touches all kinds of other things. It has lots of impacts. And so I put this kind of chart together. I don't know if this shows up, but it shows solar cooking in the middle, and all of the ways that it impacts things, like reduced deforestation, if you're not using a lot of wood, fuel cost savings, disaster relief. When you don't have electricity or a source of fuel, you can use these immediately. Women's safety and women and children's safety, no breathing smoke in your house. Child health. Job creation, because you freeze up your time so you can do other work. So it has all these other impacts that are very important around the world, especially with women who do most of the cooking in the world. There you go. Yeah. And so you can see how the solar cooker idea can have a major impact on a lot of other areas. And in some way it touches on all of the sustainable development goals from the UN that have been identified. So the more you get into it, you realize all these impacts that are potential available. So we have the people in solar household energy. Back in 2003, they were winners of a prize from the World Bank with the hot pot. And they developed this design, and it was very cleverly engineered so that the reflector folds up into a flat pack. Very convenient for shipping. And this was designed by some engineers down at Florida Solar Energy Center, and a lot of other people got involved in this. And they got some awards for this program. So it's had some recognition. They have produced these hot pots. Here's an example of the mass production of hot pots that were done down in Mexico.
Oh, that's the thing of beauty. Seriously.
Yeah.
Oh yeah.
Yeah. So I'd like to show how, you know, these things can be used by the women out in the rural areas. I have a picture of 6 women cooking food for their 6 households down in Oaxaca. We have a program ongoing down in Oaxaca, Mexico, southern sunny Mexico, and they lay out these Haynes solar cookers out in the sun like a day like this, and then they just hang out in the shade of a tree and chat and have a good time.
Sure.
Life is good. No more chopping wood and gathering firewood and stirring pots, and all that work goes away with solar cooking. And so as they do this, they're beginning to learn how to adjust their lifestyle to this cycle, and their main meal is in the early afternoon, so it's suitable for this kind of a process. And if you have to have a dinner late in the evening, we have a solution for that too, which is an insulated container, like a basket, that can contain a lot of the hot pots and food until dinner time, and that works pretty well. So what I've been doing is measurements of these solar cookers. That was the little niche that I figured I could contribute to. And so starting in 2015, I started making detailed measurements. I built an instrumentation package, this unit here. And this is called a Stevenson box, which is used by meteorologists to measure temperature inside a box. They keep the thermometers cool, but wind blows through it, a breeze blows through it, so it doesn't get overheated like a car. It stays at about ambient temperature, and they use these to measure temperatures. And so I don't know if you want me to get up or walk around.
Sure, let's look at this. Okay, yeah.
Okay, I'm going to open up this door and show you the inside.
Sure.
So this is a collection of instruments that we can use for the data loggers and testing of the temperature and some other parameters. So this is a pyranometer. Here's another pyranometer that's a tilted, gives you the tilted irradiance. Here's another pyranometer as a calibrator. And then this is an anemometer. And these are weather instruments. So we have those. You know, the inside, if you can take a look inside here, we have a charge controller that hooks up to this solar panel to power some of the instruments. And then above that, we have 2 data loggers. And these are commercial off-the-shelf products. And one of them has 4 channels of analog to digital converter, 16-bit, that records the anemometers and pyranometers. And then the other one records 4 thermocouples. These are little temperature sensors. They're very tiny. They look like this. And you can just stick these in a pot or somewhere and measure the temperature of either in the pot or around the outside or wherever we want to get a measurement to get an idea of what's going on in these cookers. So I have continued to work on these kind of measurements. I did a whole sequence of standardized measurements starting in 2015. Now, I ought to mention also, in terms of the science behind solar cooking, a big step forward was made by Dr. Paul Funk, who lives down in New Mexico, and he wrote his PhD thesis on solar cookers. Probably the only one that's ever been done. But he developed a protocol for measuring the power of a solar cooker in a standard way, so that we could do a fair comparison between these different products based on how much power do they put out. Power is the key number that you want to have, not temperature, because we're cooking food. Food has water in it usually, and so it gets up to boiling point and stays there until you get rid of all the water and start burning your food. So we don't want to do that. We just want to know how much power does it have to get up to 100 degrees Celsius. And that's the standard measurement. You know, if you talk about a car, like if you have a race car or a Corvette or some powerful car, people ask how many horsepower does it have, right? They don't ask how hot does the engine get, right? So we like to focus on the concept of the heating power of the device. And that's what gives you an idea of how much it will cook, how fast it will cook, and so forth. Now, of course, solar cookers, the cooking time is also a little tricky, because you can think of the cooking time as the wall clock time. How long does it just sit out here until it's cooked? But you could also think of it in terms of the labor time for the cook. And if you think of it as labor time, it's minimal. It's just put the food in the pot, go do something else useful. You don't have to stay around and watch the pot. You know, if you're someplace in Africa, you might have to keep the goats out of the pot, you know, something like that. But other than that, you know, you got to have a way of eliminating work, and that's what this does. So typically, this kind of these panel solar cookers will cook a meal in an hour and a half or so in the sun, and that's just free time basically. No gathering firewood, no chopping wood, no cleaning a fire, no starting a fire, stopping a fire, no messing with fire at all. Simply letting the food cook in the sun. And so it's a very simple concept, labor saving, and so that's when I started getting excited about it. So in 2015, I started collecting data, and this is the data books that I have to show you here. These are, for every experiment, I put together a standard form for recording all the background information. So here's an example. My technician, location, product tested, various parameters for the test, when started, when finished, and every hour I would have to, sometimes you have to turn these solar cookers every hour or so to line up with the sun's, the elevation, altitude of the sun, and the horizontal angle of toward the sun. So we would do that about every hour, record the temperatures, humidities, luminance, angle, so forth. I also had the data loggers to electronically record all this data. This was just a manual backup for the data. So we did these experiments. This is 2015, 2016, 2017, 2018, and then I kind of get tired of this.
Sure.
So we collected a lot of, I wanted to have a good base of data to start looking at for various experiments. And here's the compilation of the results. These are plots of the data logger data outputs. And so sometimes they're a little bumpy because we had clouds in the way, and sometimes it was kind of smooth if we had a nice clear day. And we had recordings of all of the data. Sometimes we put two thermocouples together to check that they both gave about the same reading. I also took photographs of every experimental setup, so we had all that. So we went through all of these different measurements. This is an example of a Haines compared to the hot pot. And you can see that the Haines got up to boiling and then just stayed there at the boiling point for the rest of the experiment. So it is, for that experiment anyway, whatever the settings were, the Haines came out a little better. But we did a lot of these experiments. We did a lot of repeats to get a lot of repeatability with different types of cookers. Here's with the Solavor box cooker.
Sure.
Lots of different things. We also looked at things like the way in which lid gaps cause heat leaks, vapor coming out of the pot. Did an experiment with dry ice to visualize that. So you can see things like that. So we get some idea of what's going on with the physics in these hot pots, and also with all the other kinds of cookers. So, you know, these are just repeated experiments on different days. Sometimes the pyranometer would show that there's clouds and it would drop out, so you don't get even heating, and those experiments usually are not very satisfactory. But we tried. Every once in a while there would be a really nice clear day like today here, and we would be able to do a very successful measurement. So we are using Dr. Paul Funk's protocol for the standard power tests. So by the end of this sequence of about 4 or 5 years of tests, we started to put together standard power test reports on the solar cookers. And this is an example of one of those, and we developed a Python code to program the data loggers to plot out graphs. So here's a typical experiment setup, and we would plot the graphs. Here's some examples of all the measurements: wind speed and water temperatures, solar irradiance. So this all went into report. Here's the final result. This one showed the power was 92 watts. So we do these, we have to do repeated experiments, different conditions, different times of the year, and we've learned a lot, I would say. So I was doing this for my own learning, but I also recorded everything and printed it all out, and so we have technical reports on our website that have all this data published. And it's for anybody to look at who wants to learn, you know, what causes what's going on, what are the effects of different tweaking different variables in the cooker. And so those are the kind of things we've been learning. So that's kind of been
that's a lot.
Project.
No, that's huge. It's I mean, the documentation for this stuff, I think up till 10 years ago was pretty much nil, and then people started to grab onto it to say, well, we really want to know. One question that's come up is if we had something like a Consumer Reports standard test that people could rely on. And now, how is this related, if at all, to the PEP test that that SCI has developed? Is this portions of it, or the whole thing, or?
It's the same protocol that Alan Bigelow developed for the PEP tests.
Sure.
And those are, you know, they're based out in Sacramento. They do tests out there, and it's designed. You know, Alan's equipment is using a custom programmable Arduino microprocessor that stores all the data, has data loggers, has similar instruments to this. My design is off-the-shelf instruments that you just plug and play. You should get about the same results. Now, we have not yet done a round-robin experiment to verify that. We'd like to do that someday.
Sure.
But we're getting close, and I think you know, it's a matter of getting good days. But I'm thinking we're similar, getting similar results from what I've seen so far. And we just want to get people around the world to start doing standard measurements of power and not trying to argue about different standards and so forth. There's a lot of confusion in the field. And sometimes I've even seen reports of somebody reports a power measurement of a solar cooker that puts out more power than it possibly could get from the sun area that they have.
Sure.
So, you know, I don't know what all is going on. Yeah. So we're trying to get the community to be more rigorous and to use more scientific methods and testing things according to a standard protocol. I should mention also that in 2016 we had a meeting in Ghana, and there's been 3 conferences around the world in which all of the cook stove researchers have gotten together, and this was done under the auspices of the Clean Cooking Alliance. And they have organized these global international conferences. One of them's in Ghana, one of them's in Nairobi, and one of them's in Nepal. And they I went to one of them, Paul Funk went to the one in Nairobi, and Alan Bigelow went to the one in Kathmandu, Nepal. So we've all been a part of contributing to this cook stove standard. And it's now an official ISO standard, 19867. It can be used for measuring the power of solar cookers. It's, of course, mainly for all kinds of fuel-based cook stoves, combustion cook stoves. It does that too. That's the main focus of it. But we had to make an effort to say, hey, we're here too. We want to be a part of the standard too, you know. And so Paul Funk's standard has been incorporated into the ISO standard now as the standard protocol for measuring the power of solar cookers.
Sure. I think of it this way. made my first solar cooker from the Hallisey model, you know, the Cooking with the Sun book, plywood box, cardboard, glass sheet, and I put an empty speckled camp pot in there, empty, just to see what the temperature would get up to. And I get back outside maybe an hour later and it's up to 280 degrees. It pretty much peaked at that, stayed at that on a good day, so more than enough for cooking. It's my first time with a solar cooker. I take out the glass lid and I reach in with my bare hand to grab the pot. And my conclusion is, I give this story to everyone that wants to know, energy is energy. And there's a certain amount that you get from whatever source, petroleum, wood, dung, or the sun, and it's making that useful. And the test, it's got to be pretty much the same to figure out, you know, how much you're getting out of a gallon of petroleum versus how much, you know, a square meter of sun. So so this is so important to know that.
That's right.
Yeah.
And I think of sometimes people, I say it's like a crock pot in your kitchen that cooks slowly, but so what? You don't even have to be home. It just cooks, you know, so it doesn't take any labor. And so the time is immaterial. Or you could think of it like you're thinking, energy is energy. Talk about a microwave oven. Microwave oven end up generating heat in the food directly from radio waves at 4250 megahertz, you know. So it pumps that vibration into the food, and then it generates a random vibration that's heat. So you know, there's lots of simple ways of we need to get the word out to explain this to people, so that they can just realize that it is an economical and easy to use idea.
Sure. There's on the big Facebook, the one SEI helped start, Solar Cookers World Network, one of the questions has been, well, hey, I've got solar panels, I've got an induction cooker, if I could do a DC to that should be fairly efficient. Well, it's more efficient maybe than others. And then some will say, well, yeah, but you lose so much energy at that transfer, but the objection is usually erased with, I've got all the time in the world, and that's free. This isn't a pipeline where I'm paying someone to squirt it into my stove or what have you. So anyway, this is amazing stuff. The Clean Cooking Alliance, Clean Cook Stove Alliance, is that what it's called? They'll do stuff like rocket stoves, and I think they work on, like, if you have indoor cooking, they're trying to come up with better ways to pipe the exhaust out and so forth to reduce that and so forth. But they also will take a look at solar cookers. Then too, the solar cooking or the clean cook.
Yes.
Yeah. Okay.
They have a clean cook stove catalog.
Okay.
And anybody can enter their product into their catalog.
Okay.
Now, they also allow you to provide your own test data. So it isn't really enforced in any way. We would hope that they can tighten up on the standards as time goes on. But that's a great resource for all kinds of ideas and products that people might want to take a look at.
One of my goals is, from Roger Haynes, I learned about the Hobo onset thermocoupler. And I actually have one, and I learned how to use it, and I hope to take every one of them. And it's not the PEP test. I'm sure there's flaws, but for me, just being your average Joe Blow trying to cook something, I figured do the liter of water, see how long it takes to bring it up to boil. When I visited Roger last year, he had his own, I think the Copenhagen, I don't know if he had the hot pot, and then he had the Simplicity out, and he had the 4 prongs out there. So. And they all did remarkably well. I mean, it wasn't as if one of them failed. I mean, they all eventually get there. One might be 5 minutes behind, 10 minutes behind. Who cares? But that was great to learn, because although it's a little bit of an expense, once you have it, you don't leave it behind your car and run over it. You know, you can use it forever.
Yeah. Right. Well, Roger has been quite energetic in developing and tweaking his design. Yes. This is his latest model, Haynes Model 2, and it's very nice and shiny, and it's cooking away here now. And let's see what the temperature is. That's been on for just about a half an hour or so. And so it's up to boiling. It's boiling in there now. It's a full boil. You can see it boiling if you look down around the side here. You can see that it's full boil.
My experience with the Haynes, decided to cook some beans. put about a cup and a half of beans, 3 cups of water, maybe a little bit more. And I put it out there, and maybe 45 minutes later, I'm looking at the top of the water, and there's bubbles, like almost as if someone mathematically made them equidistant apart all the way across, an even boil. I compare that to, say, the SK14 or a parabolic, where you have mostly heat in one corner of the pot. You know, no matter how you focus it, it's going to be concentrated in one area there. So that's where you see the rolling boil. The rest is plenty hot, but it's not as evenly distributed. The amazing thing with this is every square inch has a few bubbles boiling through the top of the pot. I don't know about you, but I mean, I'm not a physicist by any means, but that just tells me there's something really super efficient about this. And what I told Roger was it's the closest approximation to a parabolic as you have with a panel cooker, I think. So that too. I mean, the hot pot first, but then when I got the Haynes, just cinches it as far as the power you can get with simple materials and so forth. So, yeah.
Well, I've been remiss in not mentioning some of the names of some of our other team, and I ought to make sure that they get mentioned. David Grossman is the president of our board, and he used to work for the International City County Management Association all over the world. And Tom Sponheim, who runs the Cooking Wiki, has joined us recently. I mentioned Louise Meyer. Janet Murphy is talented in video production, and she's been working on a lot of things. Of course, I showed pictures of Richard Stoltz. He was early on involved with the development of that award-winning hot pot design, working with Dara Curtis and Louise early on in the project. And he was there in the photo with the recipients of that award. So we really appreciate that. We have a lot of other folks involved, of course, and of course our executive director is Sophie Lyman, and Sophie was going to be here today, but she's got 2 little kids, and thank God we got some young people involved in this business, you know. And she has been championing and pioneering this work down in Oaxaca, Mexico, with a woman named Lorena Harp, and also we have a woman who works at a university in Mexico, Margarita Ballo, and she has been working with us for many years, promoting solar cooking in Mexico. And so the project in Mexico is, I would say, going very well. It's called an ambassador program, because the idea was to start getting some women excited about hands-on doing it themselves, learn about it, try out some recipes, and become kind of a coach for other people, and then spread the word around in the village, sell some solar cookers, and ultimately make this into a sustainable business. And so that's the concept. We're getting there. It's been about 3 years it's been running, and it's growing, and a lot of people are excited about it down there. So it's not fast. It's not like cell phones or something. It is not going to grow like that. But it is growing organically from village to village, and we're real happy with the results that we hear from them. We had our, Sophie just put together our annual report for last year, and even though we were in the middle of COVID, we have a lot of activities going on around the world. And, you know, I can't really highlight all those things here for you now, but we have been working in many countries, working in Sub-Saharan Africa and Haiti and in Mexico and lots of other areas. So we're hoping that more people will get involved in this, particularly young people. When they will just kind of, the light bulb will go off, and they'll realize this is a space that can be developed. That's we have now a basis for solid physical measurements, standards in place. You know, so the sky's the limit. Sure.
And the website, Solar Household Energy Inc., SHE-Inc.
Yes.
.com?
SHE-Inc. Or you can just put in solarhousehold.org.
Sure.
And it'll redirect to that.
Okay.
Yeah. Yeah, so let me show you some of these solar cookers.
Sure.
We can walk around a little bit.
Yes, let's do
I
that.
have a pyrometer here, and I can measure the surface temperature and get an idea what that looks like.
Yep.
Here. So this one has been just cooking a liter of water.
Here, I will get
you know,
this on here.
the power standard calls for 7 liters per square meter of area. So it's a little bit more for something like this, about half a square meter area. You use about 3.5 liters of water, which is like a good capacity of a pot.
Sure.
And that would be the standard. But if you use 1 liter, it should cook a lot faster. So the temperature here is on the outside of this cover. See, it's got this conical polycarbonate cover. It's measuring 140 degrees Fahrenheit. All right. But the inside is boiling. You can see it's in a full boil and the water is bubbling. So that's working very well. This is my dinner tonight. And it's about 130 degrees and it's cooking nicely.
Oh, that's beautiful.
That's just some curry that I have cooking there. And this is the hot pot. I just put a pot of water in here, a liter of water. It's 150 degrees on the outside of the bowl here, but I'm sure it's getting near boiling inside. And we have the Hanes Model 1 here. This is just the reflector. See, it's somewhat smaller than the Model 2, a little less power, about 40 watts. And that is very easy to make out of a sheet of metallized plastic film. Another concept that we are thinking about is using palm leaf matting as a backing and then put some kind of plastic film, shiny plastic film on the cover. These are some of Sharon Clausen's sheets of material, but this gives you the same idea. You can, and palm leaf matting and straw and baskets and things like that, that is technology that is known by women all over the world. So we're thinking if you could go to a local place, say in West Africa, you could probably recruit some women to make solar cookers for you out of local materials. Okay, so you wouldn't need to have the plastic material. All you have to have is that little shiny surface made out of metallized plastic film, which is very low cost. And you know, you see it made of potato chip bags, candy wrappers made out of this material. It's all over the world, and that's all you need. I was in India in a meeting back in about 4 years ago, and while people were in a conference, I was hanging out, walking around the neighborhood, and I scrounged together some pieces of cardboard and some wire. Got a little black pot, and I made a solar cooker and cooked a pot of rice on the roof of the building there during the day, and I brought it down and showed it to them at night, and we ate it for dinner. So you can make it locally out of anything, you know, out of trash. So these things, and that's the concept, that's what Roger Hanes has been trying to do, drive down the cost to make it affordable really all over the world. That's really the challenge that we're working on now, where you don't need sheet metal, you don't need glass, you don't need heavy materials, just lightweight local materials that are readily available. Just have some skilled workers put them together, and you can make effective solar cookers.
Sure. And I know one of the debates is to make them here and ship them there, or do you try to make as much of it over there? And the basic thing with the Hanes is, of course, it's so lightweight and compact that you could make probably plenty here, and the shipping is not going to make it an exorbitant expense.
Right. Well, Roger Hanes has a warehouse with a pallet full of this material already in Nairobi, Kenya.
Okay.
Ready to go as soon as we get the people, the planning together. So we have to meet government safety standards and so forth. As soon as we get all that lined up, he's willing and able to get that going. And we have an interest in the refugee camps, places like Kenya and Kakuma, Turkana, Dadaab, some of these refugee camps. Also in Uganda, there's a lot of refugee camps, people coming out of South Sudan. So Roger is working with the Rotary clubs in Uganda to expand visibility of solar cookers. I'm a Rotarian too.
Okay.
And yeah, we have I'm in the North Bethesda Rotary Club, and we're doing a lot. There's a new focus in Rotary on environmental issues this year. That's a new top level, one of their pillars, their strategies. And so there's going to be a lot more focus on issues about climate change and environmental awareness. So I'm really grateful for that.
Jennifer Gasser, just last week when we visited Jennifer and Mary, when I asked her what's the big tip you could give to people if they're going to promote, overseas or in their own community, and she said, ask people what they need first. Really just make that direct connection. And it sounds like that's what the Rotarians are doing. Solar Household Energy, obviously.
Well, let me respond to that. Some time back, Steve Jobs said, a lot of times people don't know what they need until you show it to them. Now, see, Steve was talking about cutting-edge technology that people had never seen before in the world, right? And so he's pointing that out. You got to make it, show it to them, then they get it, and then they'll adopt it. And so I think solar cookers are fit in that category.
Yes.
It's not a felt need, but once they see it and start putting, their wheels start turning and they start thinking about the impacts this could have, then they'll get it.
Sure. Well, and that's the question that comes up. People are deforesting, or they're drinking water out of a stream that's obviously been contaminated with bugs and stuff. And how do you get them to stop acting against their own economic and health self-interest? So that's the eternal challenge, I think, out there.
Yep, and we're very grateful for Dr. Bob Metcalf, who developed the idea that you can pasteurize water at 70 degrees C. You do not have to get it all the way up to boiling. And so a very low power solar cooker would easily pasteurize water for you in the sun. And they developed this WAPI, this little instrument, water pasteurization indicator that melts at 70 degrees C or so, and so you can indicate when the water is safe to drink. Very low cost, simple solution. That's the kind of what I call appropriate technology that really is needed around the world. There's an organization, maybe you want to visit sometime, down in South Florida, called ECHO, which means Ecological Concerns for Hunger Organization. And they work on all kinds of appropriate technology ideas that are suitable for low-income countries around the world, and like manual devices that do what we do with electricity. Water pumps and meat, like grain grinders, corn grinders, and they have a whole collection of solar cookers down there.
Wow.
Among other things.
Whereabouts in Florida?
Food dryers. It's down near Fort Myers.
Okay, sure.
And they mainly do agricultural ideas. They have a small agricultural farm, and they've been developing seeds for better products with better seeds for use around the world. And they're promoting things like moringa trees with things like that. So a lot of interesting ideas flowing out. These are scientists that are humanitarian, devoted to trying to get these ideas out there where they can be visible. So I just put a plug in for them.
Oh, no, great. In fact, next June, I hope to come back out east. I've got about a couple dozen people that I contacted. I literally was overwhelmed. I think I contacted 30 out west last October, and I ended up with 12. So I contacted 30 this time, and ended up with nearly 20. And I had to kind of stop at a certain point, because I did want to say, well, I might be there, whatever, and never show up. And 2 or 3 of them were in Florida, but that one I had not heard about, so I'll definitely be adding them to the contact list. So
good.
Yeah. Well, any other tips? Any particular stories? You must have been to some of these countries with the cookers, or? Yeah.
Oh yeah. Well, we did in this conference in Ghana, in Accra. They had this solar cooking, or rather, this Clean Cook Stove Alliance conference. And it was a big deal, and they had like 30 countries represented, lots of people. They had a trade show. They had a lot of the people brought their products. Of course, they're mostly cook stoves of various kinds. And so I had the solar cooker display there. And I was walking around, and I was looking at the various products that were on sale, or demos anyway. And like they had this very beautiful, massive, chrome-plated cook stove that you could get it any color you want, you know, and just sign here, $650 or whatever, you know, something like that. And I'm thinking, I thought, you know, we're trying to get this stuff into the low-income people. And in the country, they're reading about the statistics, and I discovered that the average income is about 5 cedis. What's a cedi? A cedi is about a quarter. So the average income in a lot of rural Ghana is about $1 a day. And what can you afford with that? And we have no conception of affordability when you get to that level. Basically, everything has to be free. And so I had to end up giving away all my solar cookers at the end of the day. I couldn't take them home. But there was, at this trade show, you know, during one of the breaks, there was nobody around the trade show except for the staff of the hotel where we're staying. And of course, they live locally. And so they were wandering around looking at these products. And there was one thing there that was a thing called a new cooking bag. And it was a big cloth bag made out of fabric scraps filled with kapok, which is a insulating fiber which can be found locally off trees for free, and it's stuffed with this kapok to make an insulated container. And you could like heat up a pot of rice or cassava in this in your regular pot, shut the heat off, stick the whole pot into this bag, zip it up, and it would completely cook. You know, the starches just continue to cook with their own heat, and then by dinner time you've got a nice hot meal. And she was selling those for like 5 cedis. They cleaned out. Yeah. Everybody bought, well, all the staff bought all those things. She was cleaned out in no time. So when you get a product that's at the right price point, that's affordable to the local people, it sells like hotcakes. Sure. You know?
And it cooks what they're used to cooking at the low and slow heat anyway, right? Yeah. Wow.
And so, you know, that was just a kind of an idea. She had rounded up some women in somewhere in urban Ghana who were poor women who needed some work, and they got these free fabric scraps, remnants, and sewed them together to make these bags. So every bag looked a little different. Sure. And they had this free kapok material inside, and they were effective for cooking food. You know, so it didn't eliminate the fire, but it shortened the amount of time you need to heat the fire. So it was a very, you know, carbon negative, energy efficient, whatever you want to call it. A very good product. So those are the kind of things that you learn just being around. You got to be in these countries to see this stuff, and that's the hard part. You know. This woman that did this, she was not African. She was from Netherlands. She came down and she committed her life basically to live there and to develop this. So sometimes it takes that kind of commitment to get these products to take off.
This is fantastic. I mean, I'm kind of at a loss for words because we've covered everything pretty well, very well, very thoroughly. I really like the idea of this. This is a text box. I think I can follow that better than the pep test stuff, and maybe even follow through and make up something like that.
You know, I was down in Kitty Hawk in Outer Banks, down in Kitty Hawk, just with my family last month for a short vacation, and we toured the museum at the Wright Brothers Museum down there. And it is really amazing to see how brilliant those guys were. They not only developed the airplane, but they had to invent various test instruments along the way. And on that kind of got me inspired about anemometers, because I agree with you. I don't want to have the expense of something like this. Sure. What we're trying to do is to develop a low-cost test instrument package that will be a fraction of the cost of this, that can be used easily around the world. And we've got most of the ideas put together, but one of the ideas is an anemometer that is low cost. And basically the standard requires that the wind speed during the test be less than, I think it's 2 meters per second, something like that. And so you just basically have a yes-no test. It doesn't have to be real accurate, but it has to indicate when it's good enough to measure. Now, today, I don't know what that average wind speed would be, but I actually started working on that. You want to see my crude prototype?
Sure.
Anyway, this is a very crude idea of an anemometer, and the only thing I can say that's good about it is it's sensitive. See, you know, it's very sensitive to a slight air movement. So it just has a little sheet of aluminum balanced on pins. So, you know, to make it really useful, the whole thing would have to be heavier to give it some inertia. Maybe a sheet of plywood or something. And then make a little board out of plywood with a couple of nails in it and a little hinge. And then you have something, and you could put a mark on it to determine if the airspeed is low enough to do the test. Just a very crude, simple kind of devices. Now that's the kind of thing that challenges me, you know. In my professional work, we did a lot of advanced signal processing with all kinds of the best equipment and 16-bit A to D converters and all this stuff. But, you know, if we're trying to make something that's really low cost, that's a whole new set of challenges. So we're working on this low-cost standard that anybody can use with simple instruments. Maybe you have to have a laptop, have Excel spreadsheet or something like that, and do these standard test protocols. So I think that can be done, and we're working on it, trying to get a package of instruments together. This was one example of the kind of things that you might want to think about. Sure. So, you know, I'm welcome to invite ideas from anywhere about better methods than this, and we would like to just get people together thinking about these things from the affordability. Oh, there's so many ideas that come up. If you were an engineer living in one of these places, you know, as I experienced this when we travel around to places in Africa and India, I just start thinking of things that can be done. For example, you know, you can do a pretty good job of solar cooking with a pile of dirt. You know, dig a hole, especially in sand, and you can put your pots in the sand, maybe put a reflector around it to concentrate some sunlight, and put a little charcoal in it to make the sand black, to absorb more light, and you got a good solar cooker. Sure. And so it doesn't take a lot. It just takes, I guess, an engineering kind of mindset to think of things like that. And the same can be done with water, or, for example, what if you want to sterilize water? What if you want to evaporate water, distill water, to get really pure water? What if you only have salt water? You know, then pasteurization is not enough. You have to get the salt out. How are you going to do that? So, you know, a lot of people start thinking about these kind of ideas. There's plenty of those kind of things with water, and I think those will grow over time. They're all over the place. But we're still not there yet with solar cookers. And I think the other concern I have is I don't think it's realistic for us to expect every woman in every household to start adopting solar cooking, because it's such a change in your daily habits, your schedule with your children and everything. I just don't think that's realistic in a lot of cases. And on the other hand, I think that there might be more ways to scale up for institutional cooking, such as cooking for a school, cooking for an orphanage, making a restaurant, other business models that should be tried out to see if we can get something to catch on. Sure. There are some of those already in India. I think they have been pioneers in a lot of these large-scale solar cooking installations. They have temples with a whole section of Scheffler or something like that mounted on the roof that heats up water for a boiler and cooks food. We saw the one, the Sikh temple in Langar Hall in the center of New Delhi, and they have a continuous feeding program. They feed you a meal. You just line up and go get free food all day and night, all year round. And that was fueled by gas, but I think a year or two ago they decided to switch to solar. and put solar collectors,
Sure.
on the roof. Yeah.
Sun-rich country.
Yep.
Too. I mean, the map. You can't argue with that map.
That's the thing that puzzles me so much is why is it we get these people from Minnesota, they're all or Canada, they're all excited about solar cooking. What about the people down in Phoenix or something like that? I was in Phoenix a few years ago, and I drove around. I noticed hardly anybody had solar panels on the roof.
Yeah.
They just don't get it. They came from the Midwest somewhere, and they retired down in Phoenix because they wanted the sunshine. And once they had air conditioning figured out, they came in droves down to Phoenix and Mesa and Scottsdale and all those cities around that vast metropolitan area now. But they never thought about the sun, and so it baffles me. It's a cultural thing that it can't be easily, rationally understood.
Sure.
Well, I was at the Brookings Institution in 2019 when Amory Lovins came in, and he is the guy from Rocky Mountain Institute who back 25 years ago he wrote this report describing how solar energy is going to become more affordable than oil someday. And he put all the calculations and projections in there. They turned out to be right. And so they came and they gave him an award to celebrate the confirmation of his report from 25 years earlier. And of course the prices are still going down. So a lot of coal-fired power plants have been shut down all over the U.S. now. And so it's just the economics that's driving it. And that's what he said. You idealists out there, that's nice, but what's really going to change it is the economics.
Sure.
And that's happening all over the place, for sure. We have some people now talking about infrastructure, and they're thinking of putting more transmission lines all over the country, making bigger grids and all that, putting in broadband and everything. And I'm thinking, no, why waste all that copper or whatever? And it brings back a memory of my dad. My dad worked in the REA, Rural Electrification Administration, and his job involved inspecting telephone poles that were constructed all over the U.S. So when I was a kid growing up, he would take me on trips, once in a while. I would go see these plants where they're making telephone poles, and that was his job, to travel all over the country. And the REA was putting wiring to all the farms all over the U.S., one of FDR's programs. And so now that, we've done that. We have electrified the country. But to do it all over again with more stuff, I don't think is necessary anymore. I just don't think, everything can be wireless, and the sun is wireless, right? So why burn some kind of fuel, put it through generators, send it on wires 100 miles away, and then run it through some more heaters, and then boil your water? What sense does that make?
None. Wow, I hadn't thought of that before. Wireless energy. Well, thank you so much. If I come up with any other questions, I'll email you. We can put, is your contact information okay to put out there? And obviously the website for Solar Household Energy. So thanks.
All right.